Now they must secure the aluminum inserts which will be embedded in the wood. This thin sheet of fiberglass will afford better support for the inserts. They will thus be more solid. To make working on it easier, the board is securely held in place by clamps. Epoxy, an extremely strong adhesive often used with composite materials, is applied to the fiberglass at room temperature. It is then essential to remove any excess epoxy as well as to eliminate all air bubbles so that there will be a good adherence. As for the top part of the board, it's made of a resistant plastic applied by silk screening. In silk screening, ink is spread by this little squeegee. This application is called a pass. Colors have to be applied one at a time. Inks must be allowed to dry for several hours between each coat. Now the board must be curved. A cover is placed on the mold. When the mold is closed, the board is given the desired curve. Heat trapped in the mold makes the epoxy set and harden. The board comes out of the mold and any excess epoxy and wood are removed by a bandsaw. To achieve a perfect cut, the saw blade is changed every 50 boards. It's highly precise work and totally manual. They apply, again by silk screening, another coat, then another color. This time, the red. The snowboard must now be protected. A protecting varnish flows as a thin curtain. The board passes beneath this curtain and then moves into a dryer for a 6-hour stay. Sanding removes surplus varnish from the edges of the board. New holes are pierced into the board to locate the inserts installed at the beginning of production. This sander removes imperfections in the hardened varnish and prepares the board for its second varnish coating. Then the plastic base is sanded to obtain the desired finish. The board is checked to see that it's perfectly flat. A razor blade verifies that the different coats are well adhered to one another. Certain boards get an engraved aluminum insert, a luxury touch. The board is finally now ready for action. This facility turns out over 500 snowboards per day in a range of some 30 different models. When most people take off their glasses, everything becomes fuzzy, except when they're wearing these contact lenses, which help you see without anybody being aware that you've even got them on. Contact lenses have been in existence for over a century. At first completely rigid, they have now become gas permeable and as flexible as gelatin. These small polyhema discs are used to make soft polymer contact lenses in a variety of colors. We see here a patient's prescription, essential to the fabrication of lenses. The process begins with data processing control of the shaping. Data is supplied by computer, which controls a digital lathe. They begin by shaping the inner curvature of the lens. This digital lathe, rotating at 6,000 revolutions per minute, is equipped with an industrial diamond. It shapes the inner surface, the part that touches the cornea. It must be free from any abrasion and imperfection, and is polished with a superfine abrasive paste. Polishing is a crucial step because it assures excellent comfort and perfect vision. A technician measures lens thickness with an extremely precise gauge. They now shape the outer surface, the part which touches the eyelid. The lens is glued with a special warm wax, and when the lens is completed, the wax will be removed by an ultrasound device. The wax takes on the desired shape in just seconds. The comfort of a lens is also determined by its thickness. It must be as thin as possible while retaining sufficient solidity. They begin by shaping the outer diameter of the lens, which takes only a few seconds. They now polish the outer surface of the lens. This polishing, done at high speed, calls for an abrasive paste, some oil, and a small polyester cotton ball. This apparatus polishes several lenses at the same time, a step that takes only 60 seconds. With everything computerized, quality is incomparable. A technician then polishes the rims of the lens. The polymer is then hydrated to make it flexible. Lenses remain immersed in a balanced pH saline solution for 24 hours. The lens becomes engorged with liquid and expands, reaching the desired proportions. This optical topographer is used to verify, through color distribution, whether the spread of optical power in the lens is precise enough to assure perfect vision. And now we proceed with another important testing procedure. The soft, fragile lenses are always handled with the greatest of care. This unit, called a frontofocometer, is a metering device which verifies the optical precision of the lens. The lenses are now completed and are cleaned, and they're stored in containers filled with a salt solution.